Good morning and welcome to day 2 of the Greater Indiana Clean Cities and 4th EV Workplace Charging Virtual Workshop presented by Nozone. My name is Carrie Garvin. I am the Executive Director for Greater Indiana Clean Cities, and I will also be the moderator for today's session. Before we begin our first session, we are going to share an electric vehicle video testimonial to get you ready for the day.
Beside the fact that it's incredibly fun to drive, I was really interested in both the electric vehicle technology and the environmental impact of the gas-powered vehicle. It's just a cool feeling to have something on the road that is, from a technology perspective, is a feat. Everybody pays attention to your car. You know, driving that is like driving a computer. I mean, you name it, I can adjust what I want. The fact that Rolls-Royce has charging stations at all of our facilities in town definitely was a big part of my decision. I have installed an app on my phone, so I just walk up, put my phone up to the charger, and it releases. It's very inexpensive. I can charge all day long for $2 or $3 and get almost a full charge on my battery. It's such a small amount I don't even notice, right? It's less than a cup of coffee a day kind of thing. We do have quite a few people that drive electric vehicles here. In fact, the stations downtown are always full. It's just becoming more and more popular. So I think they realize that this is a need for the employees for sure. I guarantee if you went to Apple, Google, any new, really ahead of their time company, they're going to have charging stations. It just speaks volumes to me about how advanced your company is, how aware they are of their environmental impact, and culturally kind of where they want to fit. This is definitely a generational thing. Young people are driving these. That's all there is to it. Anybody that's trying to attract young talent, just from a retention and attraction perspective, it's something to be aware of. And I'd certainly think about, if I were going to leave Rolls-Royce, that would be a consideration for me. Does your company have charge ports? If it didn't, I don't know if I'd be interested. I don't think I'll ever drive another gas-powered vehicle. I love it. Yeah. I don't know. I'd never go back.
I love these videos. So hopefully you guys joined us yesterday and got to catch a couple more. If you haven't, they are all located on the Whova platform under subsessions. So I highly recommend you guys checking those out. Now for today's session, removing the red tape, EV charging infrastructure, permitting and code. We will hear from Jesse Bennett, Research Engineer at the National Renewable Energy Lab, or also known as NREL. We will also hear from Jordan Walpe, Electric Transportation Project Manager at Duke Energy, and Alexia Lopez, the Planning Administrator for the City of Carmel, and Lauren Travis, Assistant Director of Sustainability for the City of Bloomington. Together, they will discuss proper permitting and codes to get your charging station up and running. Just as a reminder, all attendees are in listen-only mode and will need to enter questions into the Q&A feature on Zoom. Please do not use the chat box, use the Q&A box, which is what we can see. We will address as many questions as possible at the end of the presentation. Now I will pass things over to our first speaker, Jesse Bennett. Welcome, Jesse.
Hi there, good morning, and thank you. And thank you all for joining us this morning. As mentioned in the video before this, the EVs are kind of really taking hold in the market right now for light duty transportation, and there's a lot of different models that are coming online, and one of the important elements to this is actually recharging the vehicles. It's a little bit of a different structure than the internal combustion engine, where there's gas stations available where you refuel your vehicle somewhat frequently, maybe once a week or so. It's a little different here, where you can charge at home, charge at your workplace. There's a lot of different opportunities because the electric grid is so vast for charging up these vehicles with electricity. And part of that, the most crucial element for that charging infrastructure is actually the EVSE itself and installing that. To make sure that's done in a safe environment, there is some, what some might refer to as red tape or regulations or requirements to make sure that these are done in a safe and reliable manner. I'll just step you through some of the high-level requirements that a couple different standards and codes place on the installation of EVSE. If you go next slide. So there are quite a bit different electric vehicle supply equipment, and I don't want to dwell on this too much, but just to kind of make sure we're all on the same page here, just talking a few different options. There's always a level 1 portable unit that sort of plugs into a 120 volt outlet, like a lot of lights and other devices in your home. These come with most vehicles as like included as a one charging option, somewhat slow, sometimes referred to as a trickle charge, but it's a great option portable to keep in the back of your car in case you need a quick boost and you're out somewhere where there's not already installed EVSE or electric vehicle supply equipment. However, level 2 is a lot more common. This has a little bit higher voltage input, and sometimes they're installed as wall mounts, very common for permanent home use installations or even pedestal style units at workplace charging programs. And the next slide, please. And then in terms of pedestal style units, it's very common for these to be offered not only as a level 2 in sort of a workplace charging environment, but also in terms of their DC fast charging capabilities or higher power devices that might be common along like rest stops or some things along highways that are more useful for longer distance travel because these higher power devices really place a lot of energy in the vehicle rather quickly. Next slide, please. But installing all of these has some similar concerns, and I just want to go through a high-level structure of the standards code here, but we're really going to focus on one element of this sort of triangle or a little group of 3 standards that I like to think of in terms of EVSE. And the first one is definitely the SAE, or Society of Automotive Engineers, and that's SAE J1772 or 1772. That's the standard that dictates how the EVSE is designed and how it works with the vehicle. That's the standard that's written that most, it's very common for EVSE to comply with. And then there's the Underwriters Laboratory, which actually approves that design and makes sure that it's designed and manufactured in a safe manner. So everything is designed safely for the user and the grid as well. But what we're going to focus on is actually the National Electric Code and NEC section 625. And this actually outlines installation requirements. So it ensures that the grid is still operating safely for the electric vehicle, and the EVSE itself is not going to cause any undue burden on the grid. Next slide. So there's a few key elements in the National Electric Code that I want to touch on, but this section 625 that details all of these installation requirements specific to EVSE is rather vast, and there's a lot of very specific requirements and small little caveats here and there that are very important to consider if you're doing a larger installation or you want to make sure that you're abiding by all of the guidelines here. But the most important thing that I think everyone should be aware of is if you're installing, say, a permanent EVSE unit, each one of those should be installed on what's referred to as a branch circuit. So if you imagine in your home, sometimes the kitchen lights are separate from, say, bedroom light. And if you go to your breaker box and you turn off one of the breakers, all the lights in, say, a bedroom would go off or in the kitchen would go off. That each one of those is referred to as a branch circuit. So each circuit breaker, it protects the branch circuit. And that's sort of how they're designated. If an EVSE is installed in your home or at a facility, each one of those must be installed on a separate branch circuit. So essentially for every charging device at your home, there will also be a corresponding circuit breaker in your circuit panel. And then in terms of that circuit breaker, or what's referred to as overcurrent protection, they must be sized for 125% of the maximum EVSE load. And this is strictly just the overcurrent protection. So this is in the event there happens to be an unsafe electrical environment and the current gets very high because of potentially a fault or some other unsafe environment. This overcurrent protection will detect that and realize that the current is much higher than it's designed to be, and it will actually open the device. You might have noticed this sometimes if you turn a lot of lights on in the same circuit, sometimes you'll, say, trip the breaker or have to go back and turn it back on. That's sort of what is protecting from overcurrent. It's making sure that there's not too much going to any one given circuit. And for these EVSE devices, you need to size them 125% of the maximum EVSE load, and that's by a current rating. So what's really common for level 2 units is to operate at 240 or 208 volts, but the current on those is typically 32 amps. So if you're sizing for 125% of that load, you would need to get a breaker that's rated for about 40 amps. In addition to that, there's also guidelines and suggestions on conductor gauge and length. The supply cord, it must meet specific requirements for each power level. It's something that you could talk to with your electrician and make sure that you're having the proper gauge, but it's very common to have something around the range of a number 8 American wire gauge and less than 25 feet. You don't want to have it up very long. You want to make sure that the conductor is sized sufficient enough for the load. And these are great questions to work with your electrician on, but that's a great basis point to start from. And then beyond that, there is a loss of primary service. So there's, if the electric grid loses power, this is a little bit more of a higher level or futuristic requirement, but in the event that the EVSE happens to have, say, a vehicle to grid or can have bidirectional charging, if the grid loses power, the EVSE is not allowed to backfeed the grid or provide electricity to the grid when there is an outage. Next slide. But really, I've summarized all that in this table here, sort of some installation requirements that you might be able to use comparing level 1 chargers versus level 2, and then say your typical home residential services like a 122/40 volts, or maybe a commercial 3-phase 208Y 120 volts. And in here we have for level 1, you can see here the breaker positions. That's sort of a requirement that you'll have for each of those breakers that you install. You need to make sure that you have spare positions for those branch circuits and the protective devices. I've highlighted those here on the right. You can see the each one of those red rectangles corresponds to a breaker position, and that holds, say, 1 breaker slot. For level 1 units, you need a single breaker position, and typically a 20 amp rating is sufficient for most EVSE units. And that's where you have a different line-to-line connections here. These are things you can work with your facility manager to make sure that you're having these installed correctly, but it's always great to have an electrician work on these and perform the installations correctly. But in terms of scoping out your service panel's capacity available, it's really just important to make sure that you have sufficient breaker position capacity. And then beyond that, for level 2 units, actually because you're using a higher voltage, you actually need 2 separate breaker positions because you're going to make a little bit more of a complicated line-to-line connection as opposed to line to neutral. And you're getting that 240 or 208 volts out of there. So instead of just 1 breaker position, you'd actually need 2 breaker positions, and you'd be working with a double pole breaker that's typically rated at 40 amps for a 32 amp EVSE. Next slide. But most of this is all designed to make sure that you're installing these devices in a way that's safe for the consumer and the utility grid. And the utility grid is important to consider because there is a lot of equipment on this system that goes from the generator to your home and many different devices in between that the utility needs to make sure is operating all of the time and can always provide electricity. So there are a lot of considerations up and down this whole spectrum here, from generation to transmission, substation, and distribution before it gets to your facility or building's load center. And really all of those equipment needs to be able to supply that load that you're going to be demanding. So if there's a new demand coming on your facility, each piece of equipment down the line must have capacity to account for that additional load on the system. Next slide. But really the most important thing that utilities are going to be considerate of in terms of what equipment they need to look at is looking at the distribution circuits. And along here, there's primary lines that carry the medium voltage power. And then there's a transformer that steps it down to a safe level for your facility. And then a secondary bank with smaller service lines that kind of go from the transformer to your facility. And really the 2 key elements here that the facility is going to be considerate of is the transformer, making sure that it's rated large enough and sized large enough to supply this new load and there's enough capacity available. And then the service lines won't be overduty or overburdened with this additional load, because you'd imagine with new electrical devices coming online, you'll probably be consuming more current. Next slide. And then from switching things back to the facility perspective, just to get your bearings here, the branch circuits and subpanels and service panel here are all lined out. And this is where you can see up at the top left of the picture, the service drop comes in from the utility and goes through a meter, some service equipment and primary panel board. These primary panel boards or service panels are really where those circuit breakers would be positioned and where you'd be potentially upgrading them. These are where most of the upgrades your facility would be considerate of. And then it also is a great picture that highlights really that branch circuit and how some of those branch circuits step out of those service panels. And actually some service panels have circuits that feed a sub panel. So if you have multiple service panels or circuit boxes at your facility, make sure that you understand the structure of each of them. If you're upgrading one, you'll most likely have to upgrade another one up the line if they're connected and working together. Next slide. Oh, back just one, yeah. So so as I mentioned, the utility company is most interested in building the grid infrastructure needed to supply the energy your new EVSE will require. That's essentially saying that for all of the equipment on the grid, it needs to make sure that it's sufficient to supply the electricity at the highest load scenario. So if you happen to install 10 EVSE, the equipment needs to be able to supply electricity in the event all 10 were turned on. And so does your facility. So if you're installing 10 new EVSE, you'll probably also need to install 10 new breakers and make sure that you have the sufficient panel capacity to support that new equipment. And for terms of the facility upgrades, that new service panel or potentially even a new interconnection if you're upgrading your service panel is something you might have to consider, as well as additional branch circuits, obviously, for each EVSE, and then the possibility of upgrading a service panel or main breaker. And we'll go into actually some of these details later on as well. There's a session later today that will go into more details, but just wanted to highlight them here right now. And the grid upgrade considerations, as I mentioned, will also be a potential new service line or potentially a distribution transformer upgrade. Next slide. And then bringing this all together, if this is sometimes rather burdensome for some people. So in addition to the opportunity to upgrade all of this equipment or install your own EVSE, many utility companies are actually offering new different service options where you might be most familiar with distribution equipment coming in from a transformer and going to the service meter or the utility meter, and then the facility owning the panel, conduit wiring, and charging station. As you can see here, there are a bunch of different options where some of the EVSE make-ready services actually are, or the utility owns the meter panel and conduit wiring, and a facility is only on the hook to install and own a charging station. Or even there's options where there's a utility full service where all the equipment is owned by the utility and an EVSE might be available for public use, as well as the opportunity for different EVSE installation support or potential financial help from the use of EVSE rebates or things of that nature that help the facilities financially installing or purchasing EVSE. Next slide. And that was all I had. Thank you for your time, and I think we'll have some time for questions afterwards. But
thank you, Jesse, for doing that fantastic overview of something that I know is very complicated for others to try and understand. So I and the rest of our speakers today will help elaborate on each of those areas. So thank you again. Our next speaker is Jordan Walty, Electric Transportation Program Manager at Duke Energy. Welcome, Jordan.
Hi, everybody. Thanks for letting me jump on here. Just a quick question. Do I look blue to you guys in the webcam? If I'm looking at myself, I look a little blue, but I'm really not.
You do look blue.
Okay. Well, thanks, Kevin. I see that. Well, ignore that and look at my PowerPoint. It's gonna be great. Here we go. All right. So yeah, sorry, pushing some buttons here. I work for Duke Energy, based out of Greensburg, Indiana, and I'm the Electric Transportation Program Manager. What that means is I'm equipped with the task to roll out charging infrastructure in our Indiana, Ohio, and Kentucky service territories. And I've been doing this about 2 years from a regulated standpoint, regulated utility standpoint, and it's been a little challenging. So we're trying to balance what a utility investment looks like with what we can get approved through different state commissions. So it's been challenging, but overall we've had really good input from stakeholders. I'll just point out Kevin from the city of Carmel. He's been very helpful with us and some of our initiatives. So having those good stakeholder engagements has been helpful. What I want to talk about today, though, kind of builds off of what Jesse just spoke about, is the coordinating your EV charging infrastructure with your local electric utility. Just got some good points to be made that will help you as you plan through that process. Next slide, please. All right, yeah, just a quick summary. I think most of you probably understand these descriptions, charging levels, but we've got the level 1. I don't, as a utility, really don't need to know if you're going to install level 1 charger at your house. It's just kind of the default that comes with your electric vehicle. We have level 2 right there. It's similar to electric dryer or electric water heater. Potentially, we may need to know about that as a utility, especially if you're maybe in a smaller home in a neighborhood that's fed off of a transformer that serves, 5 to 6 other homes. We might need to know about that. So if you do see some flicker or voltage fluctuations in your home, and if you do plug and play your EV car there, let us know. We can come do a study on your meter and see what your power quality is there. For fast charging, absolutely, yes. We would love to know about your fast charging installations to ensure we have adequate three-phase capacity for you on the site. And so coordinating early and often with your utility is great and helpful, especially around rates and demand charges. Well, we can work through that together. And then extreme high-powered DC fast charge, when that comes, yes, we'll definitely need to be knowing about that, especially for large fleet deployments. Next slide, please. Okay, so this is an automated slide, so click one more time. All right, so as you get going, so this is just the tip of the iceberg when you start planning for EV SE. And I know Jesse tackled some of these points, but really what you see is I know I'm going to buy an EV and I need a charger. And so that's where you start. So then what else do you understand as you move on down the road? Next, or just click, yeah. So you'll definitely want to check your facility electric infrastructure. Quick point on that, I've been working with several stakeholders to submit applications for their Volkswagen applications in Indiana, Ohio. And I was surprised to know that some of the applicants, when you get into the understanding what your current facility has, like where's the load center, how's it metered, how much capacity do you have on your load center, it was kind of a challenge. So I think as we move forward, understanding what your electric capacity is in that load center on your site, that's a non-utility asset, is going to be very helpful. So I would get with an electrical engineer or your electrician as soon as possible if you're going to look into a fleet, EV fleets. Next click, I suppose. Then you'll get into, and that's kind of where you take a look at your on-site equipment, and then you need to reach out to the utility and have that conversation. And that's where the two, when I talk about the Volkswagen application, that's where those two come together, and there has to be coordination. There has to be lots of just clear understanding of what the project is. And so as a utility, once, as we get more experience moving on, our local engineers will be able to help with that. Folks like myself who are kind of managing programs, EV programs, can help with that. And this is where the utility is going to grow in the future as more EVs come on. Go to the next click. And then if you want, I know this is popular in some places, is distributed energy resources. So maybe you're going to put up let's take this for example. There are some school systems that are going into electric school buses, and they also have a solar grid on site. And so how do we coordinate the school bus charging with maybe any excess solar capacity that we can direct into the bus, or theoretically direct into the bus? So all these discussions need to happen as you look to expand your EV fleet. One more thing on the utility service infrastructure. Sometimes when you get going with your utility, there might be a cost. Say you're going to install a fast charger, and there's no three-phase facility nearby. So there may be a cost in what we call as a cost in aid of construction. CIAC is what people will call that. You may have an upfront service cost to get that facility installed. So just be aware of that. That's the point of working with your utility early on, so you really understand what costs you're looking at. Let's go to the next slide, please. All right, yep. Jesse really, I think he had a good diagram, maybe a little better diagram than this one, but essentially utility, we're going to do the green part. You know, that's kind of our bread and butter. We'll do the grid, we'll do the transformer, we'll do the meter. And then after that, you get into the blue section, which is the electric panel and switchgear. More customer responsibility. Customer needs to understand that and make any adjustments as needed. Charger, typically customer owned, but in some situations utility would own it. And so you just got to work together on that and see what best fits that application. And then obviously the vehicle would be mainly used by the end user. So all this, needless to say, there's several components to deploying an EV fleet, several things to think about, and it's essential to have the utility involved from day one when it comes to planning your EV fleet. Next slide, please. All right, so for example, this is what a good planning session looks like with your EV utility or your electric utility. Right here, we've got 4 electric vehicle trucks. Let's say they are day trip trucks. It's a beverage distributor, and they're making 60-mile routes each day, and they have 4 electric vehicle delivery trucks. So here's how you can charge these trucks. So on load profile for scenario 1, the blue one on the left, you would charge your 4 trucks for 2 hours at the same time from 9 p.m. to 11 p.m. Your peak demand would be through the roof. You'd have 4 fast chargers. Your peak demand would be 600 kW. Your energy delivered would be 1,200 kilowatt hours, and your bill would be effectively $7,800 a month or 22 cents per kilowatt hour. Now, for scenario 2 on the right, let's say we take those 4 EV trucks and we charge them at 50 kW. Still like the lowest fast charge rate, but it's the charging time's a little slower. But it's still done overnight, and it doesn't really impact your use case for your trucks. Your peak demand is not 600, it's actually 200 kW. Your same amount of energy delivered, so the batteries are still fully charged, either option at the beginning of the next day, but your monthly bill is literally half of what it was if you were just fast charging in a shorter time frame. So that is planning 101, and I would highly encourage that with if you are considering that as a fleet deployment, to definitely do this calculation with your electric utility or account managers or whoever your representative is as soon as possible. That will help you save a ton of money and a ton of headaches in the long run. And your infrastructure, it looks like at 50 kW, infrastructure costs will be a lot less upfront as well. Next slide, please. So a few takeaways here. I've got 2 pages of takeaways here. So engage with your utility early and often. I think I've hit on that quite well. The time, so some service upgrades take a while. So if we have to go outside or go on site, and let's say you're doing a fleet deployment at your business, and you're going to do 10 EV charging stations, level 2, and we need to upgrade the transformer. But we get on site and we realize, well, this pole's out of code, so we need to upgrade the pole and possibly some service conductors and some other whatnot. So there could be a lot more work that a utility has to do than just upgrade a transformer. So keep that in mind. Always start early and let the utility know what you want, and so it's a clear expectation. Get the economics right. Yeah, so you're definitely, this is a total cost of ownership. I think everybody knows this. EVs in the long run, especially fleet vehicles, the total cost of ownership is already lower. So just making sure you understand that whole calculation, working with your utility, potentially your fleet, your automobile provider, and some of the charging stations, just getting that whole calculation correct would be very helpful upfront. And we as a utility can help you with rates, optimize your charging schedule, and make sure it's a good fit for you. Before buying the EV, plan how to charge it. Yeah, absolutely. In the Midwest, there's not a lot of what I would call EV time of use rates. There are some commercial time of use rates out there, and the time of use rates you should ask about to see how that would help you charge, see if there's any penalties if you charge on peak. You need to plan those out as well. Next slide, please. All right, choose a charging solution that meets your needs. This goes back to that scenario I just showed you. It doesn't always make sense to charge your electric vehicle with the highest power fast charger when you can get by with a 50 kW fast charger, and it will cost you less to install and less to operate. So you definitely need to think through the different options that you have. Some people say, you know, why do I need a level 2 charger at home? Well, you're right. Maybe you don't. Depending on your needs, you might just use the default level 1 plug-in that you have. So you really need to think about that. Number 5, EV fleets require cooperation between fleet operators and energy managers. So that goes back to my comment about the Volkswagen applications. A lot of fleet operators will not necessarily talk to energy managers or your building energy managers. We see that at Duke Energy even. We historically have ICE vehicles for our fleet, and now we're trying to transition to electric vehicles, and trying to get the fleet managers on board with electric has been a challenge. So, and that's at a utility company. So and it's not uncommon. We really need to bring those two folks together so they understand what an electric vehicle is and how it operates. Number 6, electricity as a fuel means thinking about fuel availability in new ways. I think everybody knows that. It's more convenient. You can charge at home. It's safe, clean, effective. And number 7, fleet operators have many options to manage cost. Yeah, so that just basically get with your utility and understand your rates and the demand charges and how that works. A lot of other, you could see turnkey service charging as a service as well. That's a new option out there that might be able to help you manage costs well, depending on your application. All right, next slide. That's it. Yeah, that's all I have. Thanks for listening, and I will pass it back to you, Kaylee. Thank you.
Thank you, Jordan. That was, I always like hearing your presentation. It gives a nice overview for people and helps them understand to get in touch with their electric utility as soon as possible and the things they need to look for at their own facilities. And as promised, our next speaker is Alexia Lopez, the Planning Administrator for the City of Carmel. Welcome.
Thank you. I am the Planning Administrator with the City of Carmel, and I also work on sustainability projects with the city whenever I can. The City of Carmel is a regional employment center in the Indianapolis region. Our population is around 100,000 now, and we process around 1,600 building permits per year. And but we only have seen so far about maybe 3 commercial EV charging stations that we've reviewed. A lot of those, some of them that are existing may have come in with the original building permit, and they may already be in, for instance, like apartment buildings and the garages. And so today I will talk about that process of if you want to submit for a commercial electric vehicle charging station. Next, thank you. So we treat commercial EV charging stations as accessory structures. And the first step for review is our ADLS amendment approval process, which is through the Planning and Zoning Office. ADLS stands for Architecture, Design, Lighting, Landscaping, and Signage. Staff will review the ADLS amendment as well as the Plan Commission Commercial Committee. The Commercial Committee will make the final decision. The process takes about 25 days from the filing deadline, and the filing fee is around $115. This is the typical process for a large installment of EV chargers with, maybe site changes or design that we need to look at, signage review. If only a few chargers are being installed with not many site changes, landscaping, or if it's not very visible from the street, then we may be able to do an administrative ADLS amendment process. And then for residential installations, only a building permit is required. Next slide, please. The ADLS amendment application is available online, so we review everything electronically now. There are no paper submittals. Before you file the online application, though, we would require a pre-submittal meeting, which can be done via the phone, a phone call, or a virtual meeting. After the application is submitted, all plans, site drawings, and elevations will also be uploaded online for review. And if needed, we may require review by the Carmel Technical Advisory Committee, or TAC, depending on the scale of the project. And TAC is made up of some of the other departments, such as fire, engineering department, utilities, etc. Staff will review your plans and issue comments electronically. The applicant will then make changes to the plans and submit information packets, we call it, for the commercial committee members. So this is kind of, we mail these out. It's kind of like a paper packet that the committee members can review ahead of the meeting. Staff issues a department report with an approval recommendation 5 days before the meeting, and then you would attend the commercial committee, and they will usually vote on the project at that meeting. Next slide. Some of the design aspects that we'll be looking at when we review your project include maybe screening for the large mechanical equipment, the size of the signage used to identify the parking spaces. This is limited to 3 square feet or less. We also look at the site layout to make sure, for instance, there's no sidewalks being blocked, or if there are trees on the site, that those are being preserved where possible. We will also want to see what color any of the mechanical equipment cabinets will be. And here you can see an example of a landscape plan that was submitted for a large EV charging station project. Next slide. So after the project receives ADLS amendment approval, then you can apply for a building permit. This is typically just an electrical permit or a meter-based inspection, where a meter-based inspection is required. Depending on the scale or the location, I think, of the project, a state release may also be required. Again, this is an online application. The cost for the permit is about $136, and the review time for that is typically about 1 to 2 weeks. So it's a pretty quick process. The residential permit is also just an electrical permit, and it costs about $73 for that. So that sums up really the process for Carmel. If you have any questions, on the next slide is my contact information, as well as the contact information if you want to, if you're ready, if you want to submit an ADLS amendment application, and that's Rachel Kiesling, she's another planning administrator with us, and Nick Mishler would be a good contact for the building permit. Thank you.
Great. Thank you, Alexia, for sharing City of Carmel's process for EV charger installations. Our next and final speaker is Lauren Travis, Assistant Director of Sustainability for the City of Bloomington. Welcome, Lauren.
Hi, Carrie, thank you. I'm Lauren Travis. I work at the City of Bloomington as the Assistant Director of Sustainability, and I am here to talk a little bit about EV charging infrastructure in Bloomington. Next slide. So first, I just wanted to give an overview of what our EV charging landscape looks like. We have a variety of public and private infrastructure. So the first are parking garages. The chargers within the municipal parking garages are available to anyone who would like to access them, as well as the new charger in Switchyard Park. There's a variety of other chargers available across Bloomington. Indiana University has quite a few, which are available to staff and students with a permit, and then there's some at College Mall, a few at some dealerships, and then other ones that are privately owned. Next slide. So first I wanted to talk about how EV infrastructure relates to our new Unified Development Ordinance. And this was passed and effective in April, so it's new, and it was an overhaul of basically our zoning and zoning requirements. So within this ordinance, the definition of an electric vehicle charging facility is a facility in which charging services are made available to the public or to members for a fee, including the structures, machinery, and equipment necessary to support an electric vehicle, including a battery charging station, rapid charging station, and battery exchange stations. Next slide. So within this ordinance, electric vehicle charging stations are permitted as an accessory use, and that's consistent across the different districts. So residential, mixed use, non-residential. There's also within the ordinance a requirement if a new parking lot is developed, so surface and above ground vehicle parking, that's above 50 spaces, there's a minimum of 1 EV parking space that needs to be provided per 25 parking spaces. And so that's just anticipating an increase in future demand. When you look at that EV charging landscape in the previous slide, it shows that we have some chargers, but we're expecting that to grow in the next decades. Next slide. So what is our process? It's pretty similar to Carmel. So if I was someone that was looking to install a level 2 charger at my workplace, or someone that was developing new infrastructure, it just depends on where it's being developed. And so we would work with Duke to make sure that your electrical is sufficient for whatever you're installing. But then if you need a site plan approval, a rezoning, or sometimes just a variance, then you would contact our planning and transportation department to schedule a pre-application meeting. And so right now everything's occurring online, and we have all of our permits online, but all staff is available to answer any questions that you may have. And then if necessary, it gets scheduled for review by our development review committee, and those are scheduled consistently approximately every 4 weeks. And if necessary, then plans can receive hearings in front of the Plan Commission if it's a rezoning or site plan review, or Board of Zoning Appeals if it's a variance or use variance. And those are all being conducted virtually as well. Next slide. So just generally in terms of deployment of EV charging stations, there's some level 2 and level 3 chargers across the city. As the city of Bloomington, we're looking to determine the future for key locations for public and private charging expansion. And there will be some new charging stations that will be built in the new city garages. So there's going to be one on 4th Street, and then a trades district garage near the mill, near City Hall. And those will predominantly be serving the downtown. So in the bottom right corner, you could see a picture of the garage. There's a live webcam of its construction. So it's still under works, but we do have some chargers that are existing downtown. And then Indiana University has invested also in their own garages at the Cyber Infrastructure Building, Henderson, Atwater, Jordan, and Feeling. Next slide. So how this fits into the broader picture, my role at the city is to help steward our sustainability goals. And one of those relates to just ensuring that electric vehicle charging stations are incorporated into new development to influence greater common infrastructure available for our citizens, and also to look internally at how we're transitioning our city, both transit fleet and city fleet vehicles to hybrid and sometimes fully electric. So the new transit buses will be fully electric, but we have an existing set of hybrid buses, and we are purchasing more all electric cars. So that's just part of continuing to evaluate what's cost effective for us as a city to lower our emissions through vehicle replacements, and then also encouraging residents themselves to look at for their next car, or where they might have opportunities to take advantage of tax credits and learn about the benefits of electric vehicles, just to make sure that we're lowering our ambient air pollution. So we're currently working on a climate action plan, which is forthcoming, and we will be including EV goals within that plan. Next slide. So thanks for having me. This is our website to learn more about our sustainability projects, but I will be available as part of our question and answer.
Thank you, Lauren, for sharing information about how the city of Bloomington is navigating the EV landscape. It's always cool to hear about the advancements cities are making to try and help not only internal staff, but then also the community adopt that those types of technologies. So thank you for that insight. We are now going to shift to our question and answer portion. Just as a reminder, please submit your questions into the Q&A box on the Zoom at the bottom of your screen. And it looks like we might have had one pop in there. All right. And as a reminder to our speakers, please go ahead and turn your cameras on so we can see you. And if you're going to answer, go ahead and unmute yourself, and otherwise keep yourself muted and if you're not talking. Our first question is, do commercial customers have to select chargers and network providers from a utilities approved products list to qualify for local city permits?
This is Jordan. I'll take this from what I know. Not necessarily. So if a utility has a rebate program or some type of financial incentive, the utility may have a list of technical specifications that the charging station needs to have, and that's kind of from a utility perspective. But as far as a local city permit, that would be a requirement that you would need to meet for the city. But in general, I think charging stations are pretty much standardized now, so you're probably going to fit both categories if there are requirements. But I'll let, I think, Alexia or Lauren chat about that one.
Yeah, we don't
Alexia.
have a list of necessarily any specific vendors that you need to use. You just need to make sure that you're purchasing a product that's compliant with the electrical requirements. So we're product agnostic. We typically post a request for proposal for if it's a city project and then look at the different vendors. But if you're installing privately, it's up to you in terms of what best suits your needs.
I agree with what Lauren said. I think she stated it perfectly. So same for Carmel.
And if I could just add one thing to that, one of the best ways to know that it's a reputable product is sort of just the basic whether or not it complies with the SAE or say the CHAdeMO standards, and then whether or not it's UL certified. So a lot of times there's the UL logo that people might be familiar with. As I mentioned earlier on, that sort of is the test and kind of a certification that proves that it's designed in a safe manner. So I know that previous utility I worked for, a lot of times with installations, they would check to make sure there was UL certification on some of the equipment.
One more thing on that. If you are unsure of anything, go ahead and ask your utility. Somebody will be able to give you a kind of a thumbs up or thumbs down as well.
Mm-hmm. Thank you. And, we did have a question pop up yesterday that I thought would be good for this panel. So I'm going to bring it back around to you guys. Yesterday, we had a question from an attendee asking about the safety of the equipment, like concerns about electrocution, fires, et cetera, and liability for the owners. So they were wanting that to sort of be covered or addressed, and I encouraged them to hop on this panel today. So Jesse, I don't know if you were going to pop in, or Jordan.
Sure, I can take that real quick, and then I'm sure Jordan might have some comments as well. But in terms of the standards themselves, like the SAE standard, it actually outlines what's referred to as sometimes the handshake, and that's sort of the communication between the EVSE, the electric charger, and the vehicle itself. So in addition to, say, the pins and contacts that provide electricity to the vehicle, there's actually a few other pins and contacts on the charging device itself that actually provide communication. And this is where the EVSE will say, check with the vehicle and make sure, all right, does your battery have space for energy? Are you in park? Are you not driving at all? Because the vehicle cannot drive forward or move at all if it's plugged into a device. So you don't have the risk of, say, if you're at a gas station, driving away with the gas nozzle. I know that sometimes the quick release, that's not an issue with EVs because they cannot drive when they're charging. And they also, the EVSEs will have a fault indicator and some fault protection inside to make sure that if there is, say, a ground fault, it will detect that and make sure there's a safe operating environment, as well as detecting the continuity between the EVSE and the vehicle to make sure that all of the contacts have sufficient conductive capability so the electricity can flow safely.
Thank you.
Echo that as well. And at least from a utility perspective, there will be, our normal protective devices on the infrastructure that we install, from transformer back to, the substation. So that all that will be there, and that acts pretty fast. If there's a fault on the line, it will definitely disconnect the line.
Thank you. Alexia, Lauren, did you want to add to that conversation? Are we good? Yeah, okay. We did get a couple more questions in. So, Alexia, go ahead.
Oh, no, I was just going to say, I don't really have much to add to that. I'm more on the planning side of things with Carmel, so I'm not really sure if that would come up, if they would deal with that, with the building permit or not.
Okay.
Unfortunately,
Okay.
sorry.
Thank you. No, that's good. I just wanted to give you an opportunity if you wanted to hop in there. Okay, so we got another question from an attendee. It says, how willing are utilities to participate in the cost of EV charging installations, since this is bringing them new users? Jordan, I think that kind of puts you on the spot, so.
Yeah, that's fine. That's a good question, and we get it often. So how willing are utilities to participate in anything EV adoption? That is going good. I think utilities definitely want to see more electric vehicles on the grid. It's kind of equivalent to the air conditioner of the 1970s. So we see low growth potential. As far as participating in the costs of the installations, it depends on what the utility. So a regulated utility can file a pilot, and you could have a rebate program that could help offset some of the cost of the charger. I think Jesse had a great slide earlier with the rebate, the make ready, all those different, ownership models. So utilities could do rebates, make ready incentives. They could do the whole thing and help deploy the whole charging station. It kind of depends what the application is, but yes, most utilities are interested. They want to help. It's not as easy as cutting a rebate. We have to go through lots of regulation approvals, and sometimes that's very difficult to get approval on. And so we are always working through that. And so there is some effort there. And I would always encourage you to ask your utility if there's any incentives out there, but be understanding that sometimes it may not be as easy as, getting a $500 rebate, but we're trying. As we also want to encourage site hosts to have a financial investment in the station, so they're able to stick with it in the long term. We don't always want to give away free stuff, so that the site host has some sort of commitment to the success of that station.
Yeah, this
Right,
is
thank
Jesse.
you.
If I could just echo that, and I don't know if it's possible to kind of go back. It was the last slide in my presentation, but yeah, there are quite a few different options that some utilities are beginning to pursue. And as sort of Jordan mentioned, this is kind of on a per utility basis. Which of the utility commissions in each state have kind of approved these type of new options? But there are new service options where you might be familiar, as I mentioned, where electric utilities equipment goes up to the meter at your house, and then you own everything like the wires and the panel, conduit, all the way to the right of that meter. There are some options. Sometimes that's some rather expensive development, especially for larger installations, and utilities are great for infrastructure development. It's kind of their entire business model. So other options are maybe they would begin building out more of that infrastructure, say beyond the meter, and then some utilities are offering sort of make ready, EVSE make ready services, where maybe the electricity rate is a little higher, but you have everything is owned up to the EVSE station, and all you have to do is install the station itself. Kind of simplifies adoption for some of these different fleets. And then there are other options where there's sort of the full service option, where even the EVSE is owned by the utility, or as Jordan mentioned, sometimes there's rebate options where the EVSE is supported financially from the utility. But yes, I've worked with the federal fleet a lot and a lot of other utilities, and utilities are very interested in finding the best way to support electrification, because as Jordan mentioned, it's kind of an increase to their load base, and it supports their business going forward. And as I've seen with the federal fleet, a lot of times it could potentially support fleets as well with lower operation and maintenance costs. So there's a lot of different options out there. And I think utility commissions across the country are getting pretty creative in how this business model might have to adjust a little bit to support all of these new opportunities.
I didn't know if Jordan was unmuting himself again, so. No, okay.
No, yeah, you did a great job. Yep.
Okay. We have another question from an attendee. It says, from your collective experience, what is the average cellular data usage per port per month in MBs? That's a fun one.
I can make a quick comment on that. I know that I think the user or the question is trying to get to how much would potentially this cost in terms of data for a networked EVSE use. And I know that a lot of times it's not as much of a concern for how much data you're using, but I know that there's some EVSE providers that if you're looking at network options as well, the network capabilities are a separate sort of annual or monthly fee, kind of a flat rate. And I believe it's usually in the range of a couple $100s per year per port. So that's kind of more or less how they charge it. That's kind of what the question is getting at. But unfortunately, I don't know specifically how much data is typically communicated. And I'm sure that varies based on whether or not you're using network connectivity for just transaction processing, or if you're also looking at more sophisticated managed charging systems and things like that. But if you're trying to scope out what a networked solution might cost on top of just the installation, I think around the range of $200 to $300 a year per port, if I remember correctly off the top of my head, is a good estimate.
Thank you. Yeah, that was an interesting one. I'm glad. Thank you for covering that. That's kind of like an afterthought that people have to think about too, because if you have a network system, you have to worry about the connectivity and it's always being online. So yeah, very good question. Okay, so I don't see any more questions up in here in the Q&A box. So I think what we can do is then wrap this up. Again, special thank you to our speakers today, Jesse, Jordan, Alexia, and Lauren. As a reminder, we have a short break before the next session, which is understanding EV site assessments and creating a plan. And that begins at 10:45 a.m. We encourage you to check out the exhibit hall by returning to the Whova platform and clicking exhibitors from the left side menu. And remember, to enter the next panel, you will need to click on the unique meeting link listed under the session in the event agenda. Enjoy the remainder of the workshop, guys. Thank you.
Thanks. Bye.
Bye.